For the last day of chapter 7, we look at solving exponential equations. Now, this is just another type of equation to solve in a long line of equations that you guys have been dealing with. If you think back in time, you've solved linear equations, you've solved quadratic equations. Think bring everything to one side, let it equal 0 and factor it. You guys have solved absolute value equations, rational equations, trigonometric equations. There's just like a massive number of equations that you guys have learned how to solve. And don't forget, you're learning tools. You're learning basic tools so that when you move into a higher level of mathematics, you are able to kind of handle whatever equation needs to be solved because of a different math concept that you've been working with. Now, for the exponential equations, what we're going to do is really focus in on the equality. The idea is very simple, as always. What you're trying to do is look at this equation and say, what value of x could you put here, and then the equation will be equal. Now, what we're going to do is we're going to again use the whole equality idea, the whole balance idea, and we're going to focus on the base. That's your technique for this guy. What we are going to do is we are going to get the bases the same. Now, I'm going to just leave this side alone. I'm going to leave it as 4 to the power x plus 2. 64 is actually 4 to the power 3. Okay, so then we put a 3 there, and there is still the x. And then we go back to our old rules of exponents, where if you have a power of a power, you are multiplying, well, it's just 3x. Now, let's go back to that equality idea. In this setup, when we take a look at 4x plus 2 and then 4, 3 plus x, this is kind of the key pivotal moment, the key piece of understanding. What we see is the equality. There is a base of 4 and a base of 4 all by themselves. Those are equal, therefore, the powers must also be equal. What we are saying is then, the x plus 2 must be exactly the same. Because again, you're trying to find what value of x makes it equal. Well, if the 4 is the same on both sides, it can be taken away and we can just focus in on the powers. If the 4s are the same, the powers must also be the same as well. And then what we've done is we've just taken it to a very simple equation to finish. We will isolate for x. I'll take this x over, divide both sides by 2, and we have it. If I shove a 1 in for x here and a 1 in for x here, we have our final answer. Now, what would be then the key? Get the bases the same. So you have to take a look at what are you given, and you have to make the bases the same. So in this guy, you might be like, oh, well, just go 4 again like letter A, but it won't work. You can't make 8 a base of 4. So it's going to be 2. That's going to be our choice. So 4 is 2 squared, and then we again have this 2x. 8 is 2 cubed, and then we have this 2x minus 3, and we have 2, multiply your powers, 4x, and on this one, here would be the rookie mistake, to just go 6x, and then a minus 3. This 3 multiplies to both, so it's minus 9. Now here we have it. If our bases are the same, and they are, they're both a 2, then we can drop the bases and say, well, the powers must also be equal. And now we can solve. In this one, I think this would be our easiest version. Take this 6x over, divide both sides by negative 2, and here's what you don't do. Don't be surprised that you have a fractional answer of 9 over 2. We know that. We're not in elementary school where we're expecting nice clean answers of 1 all the time. This is solving the equation. Now, the next one might be just a little bit redundant then once you see the idea, but let's do it just because then we have another base. For our third example, we have 9 to the power 4x equals 27 to the power x minus 1, and what would then be the choice of base? If you scan your 9 and your 27, they could both be broken down into a 3. So this one would be 3 squared, and then the 4x. Don't worry about your use of brackets, just know you have to multiply them. 27 is 3 cubed, and then again, this is very important that you remember it's the distributive property there. So what would we have? 3 to the power 8x equals 3 to the power 3x minus 3, and we are ready for our grand finale. Our base is now the same. We can take 8 and let it equal 3x minus 3. If the bases are the same, the exponents must also be equal, and it's a pretty quick solve. Subtract 3x over, divide both sides by 5, and we have negative 3/5. Now, our final two examples, They really do show how all of your work in previous math courses is very, very important. It's why we don't just let this course go. These are all necessary skills for something coming later on. So here's where we're going to use a little bit of your grade 8 work with exponents. We take a look at this guy, and we have to make the bases the same. And you're scratching your head going, I wonder what we're going to do. It's going to be 2. So I'm going to work on the right side first. That one's pretty straightforward. It is a 2 cubed, and we will remember to do the distributive property. But then how can we rewrite this one? Here's what you have to remember. We can use negative exponents. 2 to the negative 1, you were supposed to, as far as grade 8, realize that a negative exponent means flip. 2 to the negative 1 really means 1 over 2 to the power 1. And so now we have it. We have 2 to the negative 1x equals 2 to the 3x minus 6. And now we can draw it. Whoops, I'll keep my colors the same. Now we can say that negative 1x is equal to 3x minus 6. And again, it's your choice on how we're going to solve. I would always look for your quickest, most efficient way to solve for x. We're going to take this x over, minus 4x. We have it equal to a negative 6. So we have 6/4 or 2/3, 3/2 if you want to reduce. Now, our final example really kind of presses that issue of you have to be able to work with negative exponents quite nicely. That's an important skill if you're going to move into a calculus-based course. So our final example would be we have 1 over 9 to the power 2x is equal to 27 to the power x plus 1. Now here is, first of all, a comforting thing. The powers, the bases, especially the bases, what we're going to move to, they're always going to be simple numbers. 2, 3, 4, 5. The odd time may be a little bit higher. It's never anything crazy. So this one, when we're trying to get the base the same, your instincts are going to be good. It's a 3. I'll, again, work on the simple side first. 27 is 3 cubed, and then we'll remember to do the distributive property. It's this side. We could do this side in 2 steps. We could say that 1 over 9 is 1 over 3 squared, and then you still have this all to the power of 2x. 1 over 3 squared really means 3 to the negative 2. And then again, it's still to the power of 2x. And this side hasn't changed. We haven't done anything with this side. So you have to be very comfortable working with those negative exponents. This would be 3 to the power negative 4x. This side is 3 to the 3x plus 3. And now we're ready for our finale. Now we're ready to say negative 4x is technically equal to 3x plus 3. And then again, what would be my method? I would take that over. Negative 7x equals 3. And divide both sides. We have a 3 over 7. Now, the final part of our notes, I'm going to squeeze it in here just so, well, maybe I won't squeeze. We got time. We'll erase, and we'll do it quite large so you guys can see it. So we're solving the equation, and in number 2, the end of the day of the notes, we just took the equation 4, and we have x plus 2 is equal to 64, and then an x. And this is the first one. This was 1a, we solved it, and we had x is equal to 1. And the big question is, well, what does that actually mean? Well, you can answer it in a couple of ways. One way, just algebraically, is you're saying if I put a value of 1 in for x there and a value of 1 in for x there, we've got it. Now, there's another way to think of it. You can also think of it graphically. So that's what I'm actually going to draw right here. What I'm going to do is I'll color code it. I'm going to draw this graph in blue. And if I was going to draw it, this is your basic memorized exponential graph that goes as follows. Now, this graph, 64x, if you just imagine y equals 64 to the power x, it's still an exponential function. What would change? It's going to go steeper, okay, on the one side, much steeper, much quicker, and on the other side, okay, just give me one moment, you guys, to draw this guy. On the other side, it'll come down more, and I even messed one thing up. I am so sorry. I'm going to redraw this guy to avoid videotaping. The 4x plus 2 is a shift. it got shifted over, and this will then make a little bit more sense. This would be like the height of 1 over here. Then, when I graph this guy in red, it's going to come as follows and go up steeper, and now it's going to make sense. Sorry about that little slip up on the graph. This spot, that is at x equals 1. That is their point of intersection if you thought of it graphically. My apologies for not drawing the blue graph first. I totally forgot about wall and window.